all your equipment here, but, I know I talk long, but I wanna make sure you guys are familiar with.
Besides the talk that we just had about some of the, you know, differences between the, Mnet and Boomi, I mean, even with, outside of that, we're looking at the same equipment. Same,
Yeah.
speed, air handler, same static control,
There you
same
go.
thing, you know, so.
Variable speed compressor, oh yeah.
At least for us that work on it in the field, if there's, you know, if there's some reason for you, Jose, to hear the details of each, piece, then please by all means, but.
No, this was supposed to be a 30-minute overview, just to make sure.
Yeah,
And there's always little ahas that come on, and obviously, you guys don't like the back of your hand. I'm here trying to figure out long-term systems and, you know, answer those compatibility questions, ease of maintenance, you guys, you know, making sure that you guys are getting what you need.
yeah.
So you're right on, Scotty, so that's the intent. We went a little bit longer on the overview. Craig has more details.
He's got
You
a
can
ton
talk
of
for
info
days
in
if
his
you have
head,
to. We give him the opportunity, which is fine. So again, the intent is overview today, 30 minutes and walk. That's the two intent. And there's gonna be ahas and nuggets, and we'll capture those.
A lot of times the things that get
80%.
brought up at a table, once you're to the point of the wrench turners anyway, as soon as you walk by it answers a million questions.
Absolutely correct.
So, yeah, most definitely.
Yeah.
This is the MK Plastics arrangement. However, you don't have belts. It's just in motor system the base is prescribed to the particular fan. Isolation during for a particular fan. They're showing here the bypass damper on the side. Again, we have 3 fans that are associated with the main plenum.
There's a belt driven in someone.
Yeah, I've seen one.
The only belt driven component that's here is the exhaust fan for the bathroom. That is correct.
We're looking last week and I was like,
Yeah.
oh, stop, there's a belt.
It's an
What's going on
inline,
there?
it's an inline, backward inclined fan. So they say cabinet fan.
Yeah.
It's inline fan.
And you're glad it has a belt so you can just plug your nose, reach in there, fling a new one on.
Right. So, one thing that's very unique about this, exhaust system, now we have to see 5 ISOs on all the fan, on the legs of the fans, and we adjust them based on the manufacturer's requirements and also for the air handlers. But on this particular system, there's actually a vibration sensor on each one of the fans, and we have all the external wiring to the control panel. It also includes, at the disconnect, at each fan, there's a pair of wires off an contact off the disconnect that runs back to the VFD. But on this particular display, they have a monitoring display or HDMI. It shows the vibration that's being omitted on that particular fan base at any given point in time. And what I did notice when we had center wind conditions, they can move around a bit because the stacks are quite high, and you'll see the changes on the display and it's impressive on how these transducers can respond based on movement. So, but they do all have a limit switch so that in the software that they'll trip and turn it down if it gets excessively aggressive with the vibration.
Those accelerometers
Correct.
have a 420 or any type of signal back to EMS.
Everything on the automation for the exhaust is all standalone internally. However, it's got a backend over IP interface. So that's you'll see.
It can't be used for us to troubleshoot bearing failure and misbalance, those type of things. The base control shut off period. The thing is, it probably has a mounting location for the accelerometers for future.
You're gonna get an alarm. You're definitely gonna get an alarm out of the exhaust system. So there's no belts on those fans. And go to where it shows the control panel. And the reason why I want to kind of a little more in depth. Sorry, yeah, I'm gonna get all busy. There's our fan curve. So on the control panel, you have, what you'll see on the display, there's an operation button, alarms and setup. And this is where we're talking about damper positions and if they're open or closed, the speed of the fans, which ones are actually, what's the set point, what's the actual value. You're gonna see that on the display. Reason why I want to elaborate more on this is that there's a different function on here that's important. And that is not just a standard operation, is that in this setup, I can't see it here in this display. There's actually a setup here for firelight safety mode, which is very, very convenient. Unfortunately, a lot of labs in the past, when you go through a firelight safety event, the exhaust has to keep running and the supplies go off. So inherently you have a set point of 1.5, all the supply or makeup air goes off, and all your rooms become highly negative. So you can't even open the doors. So we had to go through elaborate means of controls to try to find a solution to it, which was basically try to tell one fan to be the lead and turn and go to a certain speed, or and at that point if it goes into bypass, you have other issues. So what's nice here is that this logic internally, they've incorporated a fire alarm mode. So we wire to that through a fire alarm module. If that module is activated, then it'll disregard standard control mode. It's going to flash fire alarm mode, and it allows us to give a certain set point in that condition, which at this point is the lowest value we can set for is 0.6. And they were talking about maybe adjusting it higher based on the door pulls, but it's at 0.6. So if you walk up to the panel and it says in firelight safety mode, it allows the exhaust to continue to run. However, it allows us to have egress, or that allows someone to get out of the building safe. Okay. You don't want to change that wiring or change that logic.
So the exhaust has to have a module, and this is a fire system.
This is the control panel that runs the entire exhaust system. That's
Okay.
standalone on a panel. We'll show you. So if it's under its normal condition, it runs at 1.5 inches of water column under a standard operating set point, and then once it gets an input, it'll say from the fire life safety system, if there's a fire event, then it'll force it because it has a higher priority. As you were programming.
That's what I'm trying to understand, is
Yep.
this input, is it hardwired from the fire system?
Yes, it's directly hardwired from a fire life safety module directly to the controller input. That's correct. Sorry. The drives that are associated to the fans themselves, they have a bypass section. But there's isolation dampers that are part of the bypass, like each one of the dampers. I personally disabled the bypass feature. In other words, if there's a driver fault or failure in that mode, it can automatically transfer to cross the line. Well, if the isolation damper is closed, I don't want the fan started. So the way I look at it, if it's got a fire safety mode, it can reduce the fan speed based on using the inverters. If something truly goes wrong and you need to run the fans bypass, it's a quick, it's a change in the program, just 99, I think it's 9906. You can say bypass active as far as in the bypass section. Then you can personally enable it yourself. I don't like to see it in an automatic transfer. I just care to disable it. I don't want anybody pushing one of the buttons that says auto transfer and all of a sudden it transfers, then we got, other issues that cause us more maintenance work. So that's what I normally do. Again, we can,
Those AGVs?
those are ABBs, that's correct. So, again, we have all the manuals for it, O&M, standard set points, talks about speeds, offsets, I think great. See that has the, and it's going to move, but I'll show you. Next section was VFDs, and we brushed on Dan faucets and ABBs. I don't know if you guys have any questions that, you have the manual buttons to push and to run a hand. Obviously, all of them should be running on automatic, it's normal condition, normal mode. We do have two styles. You have your standard ACH 550 drive with bypasses. They're outside, obviously, they're NEMA 3. Inside the air handlers, might be NEMA 1. But again, all air handlers have Danfoss, the exhaust system, and the pumps have ABDs, but they all have bypasses. The exhaust fan 4, it has an ABB drive with a bypass section. However, the drive's been programmed for a fixed min-max, so it's just constant volume. It has a belt and those kinds of things, however, it's really set there for a fixed speed. It doesn't adjust. So.
Sit on the startup or whatever.
Yeah, the min-max values are set the same on those drives, and it's gonna show up our startup documentation that shows that's the condition. So if you don't have any other questions on it. And then we go into, scroll down here. Okay, so about analog inputs and outputs and how the jumpers are set in those drives and those kinds of things. You have your ABD keypad, all the parameters that are associated to them. Let's see, just kind of scroll a little further. There's your exhaust fan 4. Inline exhaust fan. And then get into Zaretsky. Zaretsky was the supplier for the Phoenix valves and the NK plastic fans to Southland. Yeah, their schedules. And we kind of go into
The exhaust fans are belt driven.
the only exhaust that's belt driven is the bathroom exhaust.
That's it.
That is it. Everything else is
There's a truck driver equipment for that last
Right.
one. Yeah, make it, no.
so. Basically, it's like a venturi valve. Get a better picture. Basically, they're networked in. Every fume hood has a monitoring panel to monitor. Give me a picture of the valve itself. Phoenix has their own controls. So there's a Phoenix controller, it's a Phoenix server that controls the valves. All you on ALC, automated logic, is we force the commands over the network, whether it be modes, unoccupied, 4 changes, 6 changes. So this is the bellows style constant volume valve. Again, linkage arm on the outside, as Jeff mentioned, just a nut you adjust, and basically by movement of the linkage arm, you change the position of the valve itself. Again, if the airflow is going through it, the differential is too wide, it closes the venturi diaphragm as close to the valve internally, and hence it can't overcome that amount of pressure, and then you won't have stability. So the concern is, as far as the differential across the valve itself, is to maintain the integrity of position of it, so it maintains the right CFM. High-speed valves have actuators on them. Again, they don't create differential pressure per se, like a VAD box would, to maintain its set point. Any questions on those types of valves? You guys seen them before, the Phoenix valves?
Similar but not,
Right, not exactly, but the style of venturi housing, just not the.
not
Right.
those,
Right.
automatically compensating,
What do we have in, Lisa?
those are actuated. They're similar, the slider
Yeah.
for the constant,
Got a damper, regular, damper, and they're not the bellow.
And you get more louder, you can have, like, if it's singles, you have duals, you have quads, based on how much airflow you need, you start stacking, because they don't start increasing the diameter of the valve, going to a 20-inch, they say, they'll use a 12, or use 2 12s. So they just stack them that way based on the demand that's required. This is what you're gonna see on the labs. The lab hood itself is a monitor. And if in fact you lose the exhaust system, you're gonna hear all these making a bunch of noise, which means you don't have the required velocity across the face of the hood. And if that's the case, then the student or whoever's in front of that hood is working in it or around it should definitely stay away from it until that alarm clears. Ironically, it's gonna be either the valve that fails or the exhaust system's off. There's no fire dampers that are impeding your flow out of the exhaust through the lab exhaust fan system. So you can mute it, but again, it's not a normal condition. It's there for people's protection. So if there's something in the hood that you don't have any vapors spilling out of the hood and consequently some digestive impact or healing, I should say.
Yeah, does each fume, valve have its own little, processor, controller?
That's correct. Phoenix, because it's critical lab requirements, they have their own control. They develop their own curves. There's like 64 points on a curve per valve to maintain the integrity when the hood goes open or closed. And they're fast reacting. The actuators from fully open to fully closed is like 15 seconds. So that if you go to open and close it, rather rapidly, then they'll respond to your change. That's not how you want to operate the hood sash, but that's the means of trying to keep people safe. If there's obviously chemicals that are behind it.
And so the monitor gets that alarm signal from that processor, from the.
Yeah, and then ultimately goes into the Phoenix server, and then we broadcast that alarm condition over BACnet to the ALC system. The thing is a little bit confusing for the commissioning stages is that a VAD box will tell you CFM. So when you have a set point and you show the graphics saying this is the CFM, you see the CFM changing, that's because it actually truly reads that value. But on a Phoenix valve, it's based on position. So you have a set point, and the set point and the value is going to be the same thing as the airflow. It's just going to be changed based on those, because it truly doesn't read the airflow across the valve.
Yeah, it's just based on this position and the assumed differential, this is what you should have.
That's correct.
Right.
So I know it's looking from the automation side, it's like that can't be possible for the CFM set point and the actual value to be the same. But that's how it's going to read.
Yeah, I saw that one day, I was looking at it down there a couple weeks ago, and I noticed that, so. But a good reminder.
Yeah. And then the last we have is basically the chill beams. My turn. Well, that is too fast, but on schedule. So it shows a sensor, SAS sensor, how it's wired to their own control system.
Going back to what we just talked about, if, say the valve didn't make it to the position the controller wanted it to be, would you then get a different number on the display?
No, what you're gonna get is you're gonna get a fume hood alarm if the fact that the,
Low, low or high,
if the room, if that is not, it's not in a negative condition, it's not maintaining an integrity velocity. Chill beam, I don't really go with the chill beams there. Chill beam wise, basically they're all the same chill beam. Being the same as that. There's a heating connection and a cooling connection, all of them. It's just that we didn't hook up the heating connection on the interiors based on design.
Good, those are the ones that leak.
Oh, they do?
These horror projects, yeah. Sharp fitting on the flex door, and leaving every time.
You talked about that when I first got here, it's sharp, heavy, I had to go back and, there's something about it, right?
Yeah, I think these are all copper connections, I believe. I don't remember seeing any kind of I think they come out with hard pipe, it's that, anything like 5/8 or half inch hard cover.
Stab right into the box with it?
Yeah, they actually made that connection when sweating it.
Oh, good.
Yeah.
There's a lot of,
Should not leak.
there's a lot of hard pipe that goes to flex into the actual chill beam. And all those hot flexes, we have like 6 of them either.
And they're not, and they just have little stubs, so they're a little fun to fix.
They're pretty good back on it.
Anyways, I guess we're gonna, next topic would be, inclusive of chill beam is, hydraulic systems. So you guys want to take a restroom break real quick? You guys look good?
Keep going and then.
Keep going.
Okay. So, yeah. So hydronically, exact opposite, all our hydronic systems come from the west, okay? Obviously, we don't produce chilled water here, we don't produce heating hot water. Well, I should say we don't produce, we don't have a boiler system, or we don't have a chilled water system here on this particular structure. We get it from your plant, okay? So, the 44-degree chilled water, talked about, which is a low temperature chilled water first. Obviously, we have the lines of connection on the west side, all 4 lines come in. We have a mechanical room, which we'll go into. In that mechanical room is a chilled water, it's a heat exchanger. So we can separate low temperature chilled water and high temperature chilled water. Low temperature chilled water goes to the air handlers. There's air handler 1, 2, and 3. And that's pretty much it. It goes to those three units. Also, I should say, in lieu that goes to a heat exchanger. So basically, there's 4 components: 4 coils, 3 coils, and then the exchanger. The heat exchanger is primarily that is to provide high temperature chilled water to only the chilled beam units. So all the chilled beams, the lowest supply water temperature is 58 degrees. So 44 degrees goes to the air handling coils if requested to be on. Obviously, the valve opens through the DEC and through the air handler request, but the high temperature hot water is through a heat exchanger. We talked about going to elaborate design of controlling the chill beams to dew point. We didn't necessarily go into the extreme of controlling the chill water, trying to get it lower and lower to get the efficiency out of the chill beams. They wanted 58. So we control at 58. However, with Sunbelt's approval and all this, we've actually incorporated dew point in most of our measurements so we can see where our offset is. That's definitely important. We have a chill beam system in our office in Garden Grove, and I work specifically on it, and that's one thing is we're driving chill water temperature down as far as we can to maintain efficiency out of them, but it's very critical as far as controlling. But at this point, it's 58 degrees. So what you don't want to do, obviously, on the exchanger from low temperature chill water to high temperature chill water is to physically open it 100% and leave it in that mode, because then you're going to take the low temperature, high temperature water temperature, and you're going to drop down to 44. So inherently what happens is then you're going to be condensating on every one of the children units, and you're going to make a rainforest in every classroom.
Neat.
So you're only monitoring dew point, but we're not doing anything with it right now, today.
Yeah.
And then, we do have the ability to adjust if we optimize in the future, taking that 58 slowly down or slowly up, depending on what we're trying to achieve.
That's correct.
And know that it will start raining at 46 degrees or whatever, if that's what's happening.
Yeah, you can start that a more elaborate routine. You could say, okay, if there's a demand request for cooling, don't allow the chill water to come 2 degrees in dew point. Or 1.5, or however you want to start fine tuning until you start getting drift throughout the building, if that be the case. But really, this whole building is driven off of chill beams. That's the primary means of cooling in this building is
They're just
chill
constant,
beams.
so we don't, it should be no touch, and let some of the other systems play the catch-up turning.
Correct. And on the chill beam system, there's actually control valves that are on the chill beams, right? So it's like I said, constant. So we have dry-driven chill water pumps. So we have a static reference, differential reference. The references are up on the 3rd level to maintain that speed as
They've
required.
been flawless and Del Norte, right?
Yeah.
Besides the leaks that we talked about,
Uh,
I just saw, okay, so,
yeah, most part.
Is there any logic if the dew point was to rise above 58?
I'm gonna ask that, basically what I wanted Bruce to say, look, if the chill water is going out above 58 degrees, we have to put a lockout in there. Let's put a lockout in there because eventually we don't have a problem with something, let's say the valve fails, the exchanger,
Okay.
right? So we continue to drop the temperature. So at that point, let's turn the pump off, right? Turn the pump off, send an alarm,
Right.
because we don't want to continue. Obviously, we have the pumps off, then we're gonna get condensating in the exchanger. We're not gonna start transmitting that temperature throughout the rest of the children, it's gonna be causing more grief than it's worth. So yes, there is some safety that are in there to assist in not having.
But, I don't know, it wouldn't be that often if the dew point did get above 58, but right now it might be.
Yeah, see, right now, this is where this monsoon weather, where the,
Yeah.
you get high humid conditions and the dew point gets. I have to do that. So, anyway, so this is the mechanical room on the side. Again, heat exchangers, and then we have 4 pumps in the room, 2 chill water pumps, and then 2 heating hot water pumps. Again, chill water only serves the 3 air handlers and the heat exchanger, the primary side, the secondary side, which is a totally isolated side, serves the chill beams. On the hydronic heating hot water side, you have 180 degree hot water. It serves the 9080 boxes, the air handler reheat coils, and also we have 2 heat exchangers. One being hydronic heating to the children units, which that temperature is a low temperature hot water, we call it, it's basically 100 degrees. That's to provide perimeter heating with the children units into a classroom or space. But the other heat exchanger we're doing is actually taking heating hot water and actually heating up the domestic. We have a double wall heat exchanger, with 2-way valve. We have a hot water generator, so we can make 140 degree domestic hot water. So we are using your plant heating hot water to make domestic on this project. So you have to have a double wall heat exchanger that separates those two, because you have chemicals that are part of your hydronic system. You don't want to jump across any, making measurements and flooding inhibited water in with domestic water. It's all being chlorinated on the domestic side. Again, it makes 140 degree water. Basically, there's a control valve that opens, a 2-position valve that maintains.
So this is a little pet thing of mine, and the pet thing of other people's too, is the temperature of domestic hot water. I agree that 140 is good, but there's a lot of, talk about 120, can't go above 120, so I guess this project was stepped out at 140, and that's okay, huh?
What we have is we have 140 that's in the hot water generator, but then we have a T&B valve, T&B1, we're talking more on the plumbing side this afternoon, but our lunch break, that provides 120 degree water to the majority of the fixtures.
Mixing.
Yeah, there's a mixing valve, and then under the bathroom sinks, you also have another, they call them T&B2 valve, that for all your faucets and sinks, instead of being 120, basically 108.
So basically 140 is the exchanger, so you don't use much volume out there, and then you get to the fixtures, that it mixes it down.
140 doesn't need mechanical room?
In the mechanic room,
It doesn't need it. 120 leaves there.
correct,
So all your lap sinks and the lower ones, the bathroom sinks.
correct. That is correct. So there's that main T&B valve that's actually in the mechanic room, which is T&B1.
That's leaking.
That's the one something. Yeah, I know they had to come back and, I wouldn't say rebuild it, but it wouldn't pull us that point. So I tried to pull it apart again to free up and brought it up to look at it, change the thermostat.
Basically with that setup, you just need a smaller heat exchanger, and you can get away, if you got that mixed value, you just can get away with a smaller heat exchange package.
Yeah, and then you have a tank, right, so the tank, then you can store a lot more water than it would be, so that.
Got the plate exchanger in there, it's pretty compact for work.
Yep. So that's, so we have high temperature chill water goes to chill beams, low temperature hot water goes to chill beams. You got low temperature chill water going to air handler coils, and the exchanger. Okay.
Jason and Christina ought to be on top of getting all the pertinent drawings.
Sure, they go through Jim, Jim will hand.
Just half the size of our monitor.
At least you can
Why
watch
is the bunch upstairs and worry about it?
No, I know where they are.
That's too hard, that's too hard in here.
See the suntan beach up there.
That's why it's not working with the overhang.
Well, I can explain why that's there. I actually tried to take it apart to figure out why it wouldn't maintain its integrity of 125, and then when I pulled this apart, unfortunately the factory had the gasket cracked. So I'm like, oh great, so now I do. So I ran throughout the entire city trying to find someone that had O-rings. I found some place on the west side, more of an industrial park. And then I walked in and the guy said, yeah, I have 2 of them. And then I said, oh, I said, how much is it? And I got to pay cash. He's like, they run a lot. And he's like, $1.25 an O-ring. I thought he was going to charge me $30 for 2 O-rings. I'm like, wow.
Yeah, I'll take
It made out today. All right. So, these are our services that come in for chill water. These lines for heating hot water and chill water. And obviously they put a mark, the heating hot water supply return, BTU meter, as well as we have, maybe a mark, but campus heating hot water BTU meter and chill water BTU meter. And then this is for the hydronic side. So, and then also you have your makeup as a backflow preventer. Backflow preventer feeds up. You have both pressure reducing valves for the hydronic side, one for chilled water and for heating hot water. Okay. So, anyways, you come up behind to the left here. This is going to be the chilled water heat exchanger. This is the exchanger that provides high temp chill water to the chill beam units. And then to my right is pump 1 and pump 2, which is about chill water.
Those are gonna be fun to work on.
They're actually not too bad.
Don't get a leak, the wet end under the motor.
Those are direct coupled, so it's the chance of fire with the seal are pretty minimal.
They originally were installed overhead. No, seriously, this was a 2-level installation. The first one, some of you saw the first plan. This was a double deck. You go up a catwalk inside this room to get to the upper level, and the pumps were above. And we said, no, that doesn't make any sense at all. Well, we don't have enough room to put everything on the floor. So then you make the room bigger. Well, we can't do that either. So went back and forth. And we did try to measure and put stand-up people walking in here. I mean, if you're wheeling in stuff, getting behind the heat exchangers, because you're gonna have to unscrew those to get in. They were up against the wall originally, so we couldn't pull out the plates. You know, there was little, again, the BIM model really helped, but it really was a huge aha, like, really? Do we even have to have this discussion today? So,
Right.
I remember that, so, yeah, you should have seen it before. Is it optimum now? Probably not, but it's definitely better than it was.
So which one you're feeding the chill beams? Which one is the line you?
Okay, so these 2 pumps are actually they're actually feeding chill beams.
The chill beams.
So ultimately, when the chill water supply goes out, it feeds. Remember, it feeds air handlers 1, 2, and 3 directly.
Straight from the line.
Correct. And then this water right here off the chill water supply comes to the control valves on the return side. So this is the primary side of the heat exchanger. This is the secondary side. This side is 44. That's why I say this control valve fails. It's going to make this side 44, which just runs at 58. Okay.
So the trick is just saying the HTC and following that over to the other side.
And that's this side is
58.
correct. This is off of these pumps.
Fine.
So it's redundancy. redundancy one or the other. So you have a strainer that's on the exchanger, right? There's your primary water coming, the strainer and the primary water. Isolation valve, you have to pull the strainers. You have the startup screens, which are back here in the back. I removed them personally. Once you did the clean and flush, I removed the startup screens, so they're back here. So if they need to go back in for whatever reason in the future, they're here. But we'll run one or the other, don't run two. There's 100% redundancy here. Obviously you don't have 100% redundancy on the exchanger, but that's basically what it's for, is to run warmer water to the chill beams. On the other west wall, or east wall, sorry, is the VFDs. Right now we have filter meter around. That's pump 1, 2, 3, and 4. The pumps are labeled, actually it's pump 1 to the right, 2, and then 3, then 4, and then you have the 4 VFDs. Pump left, yeah, left is 1, up to 4. Air separator for the chill water. Air separator for the low temp heating hot water. Again, this is your heat exchanger for your heating on your chill beams. So you have high temp hot water, and then low temp chill water, low temp hot water, and the 2 pumps that support the chill beam units. Obviously, if there's no demand request, it's not going to start the pumps up to provide heating to the chill beam units.
We're 120, 140?
100 degrees on the chill beam.
100.
Yeah, low temp hot water.
Right.
High temp hot water comes from your facility, which would be like 180.
180. Okay.
Correct. So 180 here and 100 here.
100, okay.
Yeah.
Getting confused with dinings, 120, 140 is dining.
We got 140, 120 here for domestic.
Correct.
Okay, so 100 here and then 140 over this other side?
100, and this is supposed to be 125.
125.
Yeah.
But dinings is 120, 140.
Yeah.
Is that right?
140
So
for dish sinks.
we got 4 different dishes, 4 different temperatures. Okay.
And out of the fixtures, you got more of these that go to what, 108 you said?
Yeah, the actual bathroom, it goes from 125 to 108.
Yeah.
We got all kinds of temperatures in this building.
Yeah, exactly.
Where did the 108 come from? That's not standard, is
It
it?
was-
It's going away for the.
108?
I think there's even a lower number for like restaurants.
I'm gonna get all those straight out. Again, we have more than one low temperature hot water.
Yeah, I mean,
Okay.
so this is your hydraulic heating hot water. That's actually going.
Oh, we don't need to worry about it, where it leaks,
This
we
is
can
your-
block it up.
What this valve right now is supposed to be closed. What they did is they put this groovy valve in here. This is causing you guys more grief than it's worth. Because we just added this,
And
it's an RFI.
Do we have a marker for the butterfly here?
That's the marker for the balancing of the exchanger. Yeah, and
There is a Sharpie? Oh, yeah.
so reason
Real
is
technical,
that
Tim, thank you.
with this valve being open 100%, that's just feeding your 180 degree water right back to your plant. So I put an RFI in for this to see either changing this valve to a two-way or actually putting a valve in the bypass. The comment back was just put a valve in the bypass, but it was, I guess, never closed. So now we obviously have a reduction in flow coming from the base building system. I don't wanna- This is chilled water, remember, right?
Yeah.
And this is for domestic. If you were to set these, you gotta set them with no pressure of the system on the bladders. You wanna set them when they're empty, or when the pressure's been omitted out of the tank. You have to just fill in the air bladder before you open them.
Right.
So I actually marked what they were set at, so in the future someone knows 25, 75.
Tim, are you gonna want any vertical mounts on those? About 6 foot or 8 foot height, or is that okay? Just off the hangers, and give you the flexibility? Okay,
Very quick movement, sorry.
okay. Just checking.
You have obviously the lead valves up top, so in fact, you have air vents. And then the one thing that's unusual, not unusual, but different is that they didn't put on the chill beam side, there's no pressure relief valves. So they have a
Should be insulated though.
PRV valve, but there's no relief on the secondary side of the exchangers.
These are so far away from anything, I don't know. I mean, there might be some heat conducted to those things, but there's no real flow.
No, that's correct.
Yeah.
Well, if in the expansion contraction, that what makes the adjustment.
Yeah, just a little back and forth, but.
Because there's air bladders in those. So again, domestic, this is a primary side for the heating hot water, and you have a secondary side which goes to the semi-line domestic hot water generator. It's got its own little pump to circulate or check valves. Obviously the set point's 140. I think the alarm's at 145. We'll go into plumbing and we'll go into how to navigate through that panel. Right here we have both pot heaters for chilled water and heating hot water. They're labeled low temperature hot water return supply and high temp chill water. That's going to be on your chill beams.
Is that world lab treated? It's treated water, right?
That's has closed loop, so you'll have to check it here.
It's treated though, right?
Treated, yes.
World lab chemicals in there?
So, yeah, exactly. Yeah, exactly. That's all that's in there. Obviously, I'll remove all the filter media, but the bypass section is on most of these units, you bypass it off. Again, that way if it's put in automatic, I select it as off, so somebody just can't turn on. You have to go to the bypass mode and put it on and then enable it and start it. Okay?
No problem.
Control.
Do we check the chemicals for the
Once a month.
closed loop? Once a month will be the building?
And then obviously this is the ALC controller for this plant. It relates your pumps, you start the drives, the outputs. But Sunbelt and Ruth will be involved with more of that control training. So that's going to be the hydraulic. That's the hydraulic plant. That's pretty much it.
So one split unit supplying here, right?
That's correct. Okay. So, and this is not the final means of securing this down. This is the Phoenix valve or Phoenix system server. This all the logic for all the Phoenix valves reside in here. Okay, this is where all the storage is recorded and for trending, and this is the server. Obviously, there's more gateways, and we're practically cleaning some of this up, but this is that's where the networking comes in, and then to group into all the controls.
Are all the Phoenix valves tied on a network to that? Their own dedicated network to
That's correct. That is correct. And then we basically do backnet over IP from ALC
link
and
between the two, right?
in between
Yeah.
the two. Yep.
But ALC is setting the set points for the
ALC setting, I guess you call it mode. We're telling,
okay.
so ALC looks at space temperature, tries to control off chill beam, based on if it goes occupied or unoccupied, based on a mode. And then basically we have 3 modes, and if we need to go to 6 air changes, then if the temperature of the chill beam valve's 100% open, then we change the mode. And so basically we're doing it in basically blocks of airflow and loss.
Right, okay. Alright.
That makes sense.
Yeah, sure. Yeah, if you're not getting to your temp set point, then go to the higher airflow mode.
Next airflow up.
Yeah,
And
right.
hopefully try to control it where the chill beam is at 80%.
Okay.
But yes, that's right. So this is our version. This is again, this is Fanco 4-1. This is going to be served by Condensing Unit 4. This is one of the split systems, and then obviously the thermostat that's a little bit loose, but on-off control. You can change the position of the what would you call it? The diffuser, if you want to angle it down or angle it up.
Why did they mount the Phoenix? Any idea why they mount the Phoenix server in a rack versus up against the wall with the diverter diverting everything on top of it? I know it's still temporary there, but could have just been, they have a modifier to put in a rack.
Yeah, I know this, other than having the actual strap around it, and that was its location,
Okay.
I can't really,
Well, those guys are kind of, I mean, this is just me guessing, but they're kind of old school and they're stuck on the tower type of platform, or something.
I would at least put it over here, not underneath, where we could have some problems. Okay, we'll figure it out.
again, a
It'll never
condensate,
happen, I'll never leave.
right, condensate pump is below the unit there. As you can see, the refrigerant piping are to the left, or above the door. This is one that has a split. This particular contingent CU4 has 2 evaporators. The one that's actually in this room, and then there's one in the main electrical room. Yeah.
I don't know, I guess that's just waiting for a trip to happen.
Yeah.
And you'll show up here going, well, now I know why it doesn't work for that.
Make sure I have it for the first year. We'll make sure it happens in the first year, so we'll take care of it.
And this is the other fan coil. This is 4-2. So you see the first number 4 being condensing number 4. So these 2 are on one condenser.
And where is that condenser at?
I'll show you. We'll go through all these so you know where they're all at.
Looks like. The lines are going up, it looks like.
They were down lower, we had to move them up because of some kind of requirement that's above the switch gear.
Electrical.
And when it rains, the water doesn't not come in, it does go out.
Room, electrical room. It's the same location on level 2. Also has a fan cooling unit. This is 8-1. The one above it obviously is 8-2. And then we have one exterior room, which is this is the one that has the 3 condensers, or excuse me, 3 evaporators. So these are stacked, and there's one that's outside. And I'll show you where it's at. These are the one that this one has the 3 evaps on one condenser.
It's like a ballroom in here.
Originally, that unit was supposed to be above here, the evaporator. So that's why we moved it over here. So if there was a concern or anything, we can at least it drips down in the middle of the floor. But yeah, it used to be above the lighting gear. So thermostat's there to your left. It was at like 75 degrees. The electrical room seems a little bit cooler, and this one probably want to feel a little more comfortable. So. Lab exhaust. Everything from this point going to the south is air handler 2. So in this particular interior area, button codes.
Should be all construction stuff.
And the 3 air handlers there.
Yeah, I'll show you exactly where they're all at. So this is off of air handler 2, and this is just chill beams with constant. I think these are constant air volume valves, and then there's a SAV in here as well. The linear on the left hand side are basically it's a transfer that goes in the corridor. The idea is you'll push all the air in here, and then it'll go down the corridor. It just transfers over.
I mean, it just loops over.
Yep.
So pressure, you keep the pressure a little bit higher here, and then excess goes over.
That's correct.
So you don't have a return.
Well, there is, just not in this space. That's correct.
Is there any sound attenuation between the trans or? Just straight down?
No, I think there's a boot. There's definitely a boot up there. Yeah, it's not open. It is a boot that comes across and goes over.
The other area with chill beams, I didn't even notice there.
So you'd have a chill water valve above this ceiling. So you know the piping for chilled water and heating hot water. Obviously, it comes out of this main area, and then it actually runs
Overhead.
Yeah, overhead, right down this, above this ceiling on this end, and it heads to the south. The shaft for the chill water piping and heating hot water piping is here on the northwest corner, just in that classroom to the right. That's where the fire damper is for supply, that off of air handler 1. And then here on the south side, it's the north side, south side, it's off air handler 2. That's the supply on that side, just around in that classroom, just into the left. Again, the piping runs, the mains run right across here. On this end is basically the shafts for the piping to go up to feed the other floors.
Is the noise we're hearing the fan, not the constant chilled water flow, right?
That's the air coming out from the constant volume valves
Okay,
feeding around the chill beam units.
okay, so this is how loud it's gonna be.
That's the noise it's gonna emit,
Oh,
based on the requirements in the engineering documents.
okay.
Was it cranked open, you have it set 100% right now though, or you got it controlling based on temp?
It's controlled on temp, yeah, from what I know, it's all controlling on temp.
The reason, Scotty, is similar to the room library. You're sitting in a
Yeah.
classroom hearing a, you know, a presentation and
Yeah, it's pretty loud when you're trying
it's
to
very loud, very loud.
keep.
Yeah,
Well,
so
those
again,
have mains running right through the middle of the overhead, the main duct
I know.
is right.
Right.
exposed.
this is different and I was hoping to get this a lot quieter. But there was no real noise specs put into the design.
Are any of the valves or anything marked as far as location? I see this blue dot, is that?
Yeah, blue dots, I think it was like CAD access.
Okay.
Yeah.
We'll take a look.
Most of the, there are main valves in here to do the chill beams, chill water and heating hot water right above here.
Okay.
So in this interior area, the lines come like straight through here and feed the chill beams, as far as heating hot water and off of this room, in this room. And then again, the lines branch off, so, about 10 feet in of that door, the lines turn left. Again, we have to support the chill beams so they wrap around the extremities,
Yeah.
but then the shaft that goes up. Just on the other side of the door to the left as you walk in, that's where the shaft is at. And then one, again, on the
The
north side
second
as
floor
well.
is the same.
Same location, all the way up, all level 3 on the north and the level 2 on the south.
valve, you know how to do that?
Yeah, right here by this blue dot. Okay. That's why I asked if they were marked, the blue
Yeah.
dots are CAVs.
Yeah.
And the chill valve should be right off.
Yeah, so you know the main's right through here. The only thing is, as far as the VADs.
So they're red
hot
dots
water
on
VADs,
We'll ask them.
those lines, the hot water VAD lines go directly down this corridor. And then air handler 3 serves east side, so that the high temp hot water lines go right through here. So it serves air handler 3, heating hot water coil and the VAD boxes.
So I missed it, where's the hot water line?
There's hot right above my head, it runs towards the east.
Okay.
Those are high temp hot water lines that feed the air handler 1, or 3, excuse me, air handler 3, and the VAD boxes that are on the east end. It's high temperature hot water. Okay. Again, all the other areas as far as chill water feed of this west
The
end.
panels removable,
Yeah,
for the ones that don't have.
Yeah, pero
they're a little
you need
tricky.
2 people to remove them.
Yeah, so I gotta try and put some,
Yeah. Small filter on the end of it, so that's air handler 1 building static pressure probe. That's for space pressure. And
Is that, do you know that there's, the sensor's right up there, or is there a tube goes all the way to the controller?
all the way up to the controller up
All
in
the
the
way
air.
up to the
All the way up.
controller.
Yep. All the way up. So the interior, this is off of air handler 1, right? 100% outside air. So it feeds the chill beams, right? Chill beams for constant volume valves. And then this here, from the right, that's lights. Constant volume valve. That's it.
this is your general exhaust, right? Or this is the general exhaust.
That's a general exhaust, that's
So
correct.
right here, the exhaust, the direct drive all the way up from the road, here, you got all the way up.
That's basically velocity, air velocity.
Yeah,
Air
okay.
velocity. You're not hearing the fan, you're hearing air velocity. So again, you have this is their SAV, providing cool air onto the glass. That's your general exhaust valve. And then again, all the chill beams have constant volume. So this will adjust based on space temperature if it gets excessively warm near the windows or cool, right?
And air pressure, right?
Well, this is a
More
pure
exhaust
classroom,
pulling
it's
in
not
these
a,
chill beams.
it's not a lab, it's a classroom,
This is a classroom.
there's no hoods.
Yep. So there was one that was supposed to have a fume hood in it.
There's a hood in the other room.
Yeah.
I guess,
I just saw someone. 100% strong.
And go around.
Yeah, yeah.
I guess if they were this,
It's kind of typical.
No, this is allowed.
Yep, it's allowed. So, you have a general exhaust, you got chill beams with constant airflow, and then you have your lab hood. Again, the lab hood volume is in conjunction with the general exhaust. They work directly in reverse of each other. Again, as you increase or decrease the sat height, you see in the velocity of feet per minute that's actually being pulled across the front of the hood. So they actually have a display on it. Again, this is your alarm monitor. So if you're in fire alarm mode, standby mode, basically that's the alarming mechanism. So if in fact you don't have the airflow, it's going to alarm.
so how's that being measured? Normally these have a little hole in the front, there's a little differential that draws air through it. Do you know how that's measured exactly? How it's determining that?
I personally don't know. I have to ask.
You have to look on the specific on control model name.
Those were put in after the fact, but there's got to be a means of probably a hot wire, maybe anemometer.
Yeah, maybe it's,
Yeah, whatever.
And they're all, it came back and we certified them all for the velocity and for us requirements, they had to be certified. Yep.
Keeping it wide open.
And the 3 exhaust fans you got on the roof, you got 24/7 rolling those?
Yes, sir.
The 3 of them?
They're staged based
they're
on
staged.
demand, yeah.
so that's the typical fume hood?
Yep.
Thank you.
In here for domestic water, there's obviously control valves and Phoenix valves above here, but there is some on domestic water return. That's part of the domestic plumbing training, but there's actually balancing valves in the ceiling space to set. There's basically Bell and Gossett circuit setters on all the returns coming back to head to set. So they're basically in these corners. But this is primarily where you're going to see the balancing valves there. There is isolation valves, there's Phoenix valves in these areas for the classrooms. I know that thing like this could remain Phoenix valves up here and the blue dot.
That's for the generals, general exhaust.
Yeah, this one's for the fumes outside. I know it's supply valves. I think they're out in the classroom area.
Right.
Primarily not in the lab itself. So this is all of air handler 1 this side. Again, that's air handler 2, typical of the chill beams in the center section. Again, that air handler returner. So from here, heading to the east, it's off of air handler 3. Again, we have 3 classrooms. It's off of air handler 3. It's on the east side. And the linears that are here are also off of air handler 3.
The what? I'm sorry?
The linears, these supply registers, these linear diffusers
okay.
are off of air handler 3. So this area is controlled by air handler 3.
Basically from this wall,
Correct.
that way is air handler 3.
That's correct.
Oh,
That's correct. And it goes all the way up.
okay.
At the very top, the windows that are at the very top, those ones have operable windows. There's what, I think there's 9, 9 operable windows up there. Actually open.
Just for building pressure?
Yeah, they have building pressure and there's some temperature control that allows them to open as well. The 9 windows that are up there are monitored by an in switch to see whether they're open or closed. It's actually it's monitored if they're open. They don't necessarily how far open, just the other if they're open or not. So
I've seen it done
they're
twice,
that way.
once time.
Basically, it's monitored close to this. If it probably goes open, then
Right.
it changes.
You're either
So they jam.
We're not monitoring both.
closed, not closed.
Yeah, we don't monitor both sides.
Always
We just monitor the closed side.
One? Okay,
Yeah.
closed and not closed.
So,
There'll be no trap there.
again, this is it's all VAV. So we have 3 rooms or 4 rooms that are VAV.
You want it?
I'm going.
Hey Jeff, you like your AOC monitor?
That's nice.
5 of them out here for you.
Great.
That's gonna be our,
And I think the sofa's over here.
It's gonna be our
I
dashboard,
wasn't
right?
sure where the sofa was gonna be.
This is where you have your VAV.
Dashboard, there we go.
Yeah, blue dot. VAV, -2. So there's 1-1, 1-2,
I didn't think about that. You did.
blue dots. VAV box with high temperature hot water reading. Typical VAV
How
design.
can I tell there's hot water on this one?
You can tell.
Well, because they're standard, so all of them are hot water.
Yeah, all the
So
VAVs
we're
are
not,
high temp hot water.
okay, but we're marking cold water lines, not hot water.
Well, the blue is supposed to be a identification of mechanical gear.
Okay.
Hot or cold,
Not hot.
Yeah.
here, so.
So it could be a mixture then, it'd be a VAV box,
Well,
it could
in
be a
the
control
discussion,
valve,
I
right?
was saying, well, these are where the valves are, and then, anyway, the ones on the perimeters have hot and everything. So, everything inside is pretty.
It gives us an idea where the equipment is.
Equipment is
Yeah,
That's
it's
good.
for,
I
and then
think
it
average-
actually has a label, it says VAV 1-2. Once you find the dot, there's a little indicator of what's in there.
And the thermostats are marked as well. So the thermostat should say the 1-2. So again, air handler 3. Now we're walking over to air handler 2. It has return air, which is the center section and everything to the south. It's ducted.
I didn't see any slots to get to the hallway.
So, obviously this is another downer room. So this room and the room right above it are off their own condensing unit. So this one's gonna be off number 7.
These are the Mr. Slims?
Not yet. This is still one of the, this is one of the other, Pumi, VRF, I should say,
One
unit.
of the city multis,
City multis.
but with only one?
2 evaporators.
Two
The one here and the one right
Oh,
above
okay,
it.
alright.
Yeah, so the 2 electrical rooms on the air side were stacked. Although there's one more evaporator on that number 8. This 7 lanes is 2 rooms, top and bottom.
It's kind of, it's a little hard to see the reason we use city multi with 2 units off one. I mean,
Yeah.
The reason why is because standard,
communication.
no, it's actually different. Standard split systems, the length of run between the condenser and evaporator, you're limited to the distance.
Yeah.
These
that
have
makes sense.
over 100-foot provisions.
The length of the.
Length of refrigerant lines.
There's a little bit of a price to pay for that.
Yeah.
Whatever, gotta get it.
That's why that came into play. And availability. So again, this room and the one above it.
Crazy.
Where
50 feet of run.
Well, we keep saying, do we want to cool, do we not want to cool?
Thank you.
Vents in and not cool, and we go back and forth on these.
is that cool junk on
Nice
this?
to go to get it 50 more
Close to
feet.
the time, it's not working.
That's amazing. But whatever.
So again, there's more valves above the ceiling space for domestic water. That serves utilities into the labs.
It's like Frankenstein lab in there.
Okay. You mentioned, is there any ones of Mr. Slims? As you can see, the thermostat type, it's different. This is a Mr. Slim unit. This has a dedicated evaporator to a dedicated condenser. This is
Okay.
when the power comes down from the condenser to the evaporator unit. So the room, this room and the room above it have dedicated condensers. I don't know why.
Because it was within 49 feet
Right,
of the
within
unit.
the length of the line.
Because it's electrical versus telecom.
Yeah.
I'm just kidding.
I don't know how that came about, but This has a different condenser.
Yeah.
So this is the two Mr. Slims are above each other, the same.
I think that's the longest made ductless split ever is the Mitsubishi Mr. Slim. And we had some here when I got here in '96. They've been here for a long time.
It's on set for 78, so it's just another. I don't know if it was, do all this magic. Right?
Electric meters also.
There you go. And she's off.
That was pretty fast response.
Because I'm standing there, didn't like it. So we can go all the way down to the end of the corridor. Oh, there's two ways to go about it. So you can either go down to the end, and there's obviously staircases on either or side, or you can go outside and go back up in it.
To the outside.
I gotta put a permanent lock. So
Sorry.
again, condensate pump, discharger, temp sensor, thermostat, MNet. That's all MNet.
Are those standalones, do they on the network, do they talk MNet as well, or?
They don't. There's no, it's a power line carrier.
Right,
It's fed through the fourth wire that's part of their design.
right.
You have a 208 single phase, a ground, and then a transmission line, which is basically a power line carrier.
Right.
Red, white, and black.
The temp sensors, they go to the VMS, right, to the computers.
Yeah, there's actually a temp sensor on the wall for alarming only for the BMS. This is the actual control thermostat. This controls it. We actually have a thermostat in the wall, or a sensor on the wall, so the BMS can monitor the room to make sure within its conditions. But it's supposed to be, so we can have a high temp alarm in the room, because we don't get that out of the Mitsubishi. And then that sets it on the end.
Discharge temp also.
Yeah, discharge our temp sensor. So that's.
It's a temp sensor. And
So
then
you'll
from
see it,
that,
you'll
they
see it
can-
on your GUI.
They can put an alarm in the logic based on the temperature, yeah. So you see the.
Turn it up to 85. Next time I tell you that they're not working.
Operable windows. So then this is the other evaporator. This is the one of the three that are associated with Fanco or condensing number 8. So this is the only one that has 3. The two, one here, one down below, and then the one that's up. That's outside.
Thank you.
Okay, so then
I heard the word cheap.
Those arms are a little chintzy, go grab one of those.
The snorkel?
yeah, there's snorkels in these rooms.
Oh,
Cheap.
It's a nice plastic bowl.
Value added.
I didn't know this, they look like it's just hair and nails or something. Huh?
Yeah, right.
Try it out.
Sweet, thank you.
Stick my head up there to get the dust off too? Is that what I should do?
That was a hair salon in here.
Exhaust valve. Those are all, those snorkels are, yeah, constant air volume, constant airflow, the general and the snorkels. Chill beam units. And then you got an SAB supplier valve for chill, for airflow and glass. Yeah, heating and
Get smart.
You know, we need
The bowl of silence? Here comes silence.
hair dryer.
That's what
It's out there 103. So we're gonna go look at 103 in 150 seconds. Exhaust fan forward. Exhaust fan forward is to the left. That's for bathroom exhaust. It's got a DFD on it. That's the only one that has a belt.
What's the size of the motor you got now? What's the size of the motor you got?
I think it's like 3/4 horsepower.
3 horse?
Yeah, mechanical space we can walk in, what's going on here?
Oh, wait till you see the rest. Shit.
Get at it.
This is small. Wait till you see the next one.
Oh, yeah.
We can store a whole shop over there. Seriously.
Air Handler 3.
Gambling hall?
Air Handler 3 main supply shaft camper.
Does it come down from above?
Goes, it feeds the floors and it goes that way to VAV
Is there
3-1.
handler 3 up above?
No, this way.
Oh, it's out there?
Yeah.
Oh, okay, I see.
Okay. And this is supply on 3. So here on 3 is a VAV unit, 2 VFDs, 1 supply, 1 return. Right now it's at 100% set. That's why you're here feeling the exhaust come out the end, because it's taking the return fan and blowing all the outside air that's going in the building, bringing it back outside for this building flush. We do have the safety bolts. We pull the safety bolts, so it'll kill the VFD. Actually turns both fans off. There's a safety bolt that's on the supply fan, a return fan cabinet as well. There is a switch, or an outlet for laptop, and we put power tools in there. Then you have a switch for the lights, so if you turn the light on, then it turns the light on inside the area. Now I put signs on every one of these cabinet doors, but in this
Oh, you got the UV light.
UV lights. So there's all your UV lights in there, UV light switches. When you go to work on these units, this door is closed, the UV lights are on. Again, I'll repeat, if you have this door closed and there's power on the unit, 120 volts, those UV lights are on. So when you're working here and you want to do filter changes, you don't want to get your eyes burnt. You want to open up this door. You make sure those UV light bulbs are off as you're working around these fans. Okay, that's the number one thing about this. Actually, number 2 thing. Number 1 thing is obviously don't get in the VFD in the cabinet when it's hot. Obviously, you have to use your own lockout tagger procedures that you have here for the campus, but there's labels on the units, obviously making sure that you don't get in them, but obviously you have your own protocol. But again, these UV lights will burn your skin, they'll burn your eyes. So make sure that when you're working in the cabinet, again, that you leave the door open and make sure they're off. There's no external switch.
What static is this operating at?
I'm going to say like 1.2.
It's pretty big for a 15 horse motor.
Yeah,
Is there multiple?
no, just one.
Just one?
I love to open it. I mean, you can see inside it. It's just basically it's a big pedestal base, a big motor, and it's direct drive right to a backward incline fan.
You got grease motors in this one? Or they're sealed?
They're greased.
They're greased?
Yeah, you can see inside it. You can see the fan running. I turn the lights on. These are the ones that have the Danfoss drives. There's a bypass on them. Obviously, chill water, hot water. There's high temp hot water. So right now they must be doing static pressure reset. So right now, hey Jeff, right now the static pressure is running at 0.728 because they're doing static pressure reset on the DV boxes. So this is duct static pressure, this is building pressure. So when you come up here, you can see the references up near the air handler. It's very nice.
Any indoor air quality, I didn't see anything inside any of the rooms. I don't remember what we did with any of that.
There is a CO2 sensor in the return of the units.
That's it. That is it.
We don't do any control with CO2 monitoring at all. Do you see that? That's pretty standard. Do you see that CO2 sensor on your map? Yeah.
I haven't seen it yet. So the BMS system will see